In the case of probe-based method, the PCR reaction mixture contains an additional component, that is the Tachman probe. From the beginning of the PCR cycle, the probe remains bound to the complementary portion of the template DNA. I have said already that probe is complementary to a portion of a template DNA. So with that portion, the probe is bound to the template DNA. So this is the case when the PCR cycle is beginning. So as I said that when reporter and quencher are in close proximity, so the fluorescence or signal that is emitted by the reporter will not be detected because the signal will be quenched by the quencher molecule. So this is the case. Now the PCR cycle is beginning. What will happen in PCR cycle? DNA polymerase will synthesize the daughter strand. So this is the template DNA 3' to 5' and 5' to 3'. So DNA polymerase will sit here and it will synthesize the complementary strand. So here this occurs. DNA polymerase is moving from the 5' to 3' direction and it is synthesizing the daughter strand. Now the situation is that the probe is bound to the template DNA at some portion. DNA polymerase is synthesizing daughter strand from the 5' end to the 3' end. So DNA polymerase is moving in this region. When DNA polymerase comes in this region, what will happen? The region is already occupied by the probe. When DNA polymerase is moving from 5' to 3' direction, it will interact with this probe because this probe is already bound to the template DNA. So what will happen in this case is that the polymerase will cut the probe. The polymerase will cut or chew up the probe by its exonuclease activity. So once the DNA polymerase interacts with the probe, then the exonuclease activity of the DNA polymerase will degrade the probe. The probe will be degraded. So once the probe is degraded, the reporter and the quencher molecule will be separated. The quencher and reporter molecule will be separated. So now this reporter, the distance becomes longer. Quencher and reporter are far apart. So the reporter molecule will now fluoresce and the signal that will be emitted by the reporter will be detected because quencher and reporter are far apart. DNA polymerase moves from 5' to 3' direction. It will interact with the probe. It will chew up the probe. Reporter and quencher will be separated and reporter will produce fluorescence and this fluorescence will be detected by the detector. So as the number of cycle of PCR increases, the signal produced by the reporter molecule will also be increased. If at the beginning of the PCR cycle the template DNA is 1, then after one PCR cycle the number of template DNA will be 2. Then in another cycle the number will be 4. So this is how the template DNA will increase. As a result, the fluorescence signal will also gradually increase. So this is how with each cycle of PCR, the probe-based method helps in the detection of the product DNA.